NASA's Spirit rover lived 20 times longer than anyone dared hope. It sent back a flood of data. But the final frames, the dying robot's last look from the Martian surface, were never shared. No press conference. No release. Just archived, unpublicized entries. What did those closing images show? And why did NASA keep them hidden? We unlock the silence after Sol 2208 to reveal Spirit's final geological discovery. NASA's Spirit rover outlived its design life by more than 20 times. It sent over 128,000 images. But the final shots, the last look from a dying robot on another planet, were quietly stored away. No press conference, no release, only archived entries, time-stamped and unpublicized. That gap left planetary scientists asking a simple question: what exactly did those closing images show? And if nothing was hidden, why weren't they shared sooner? The silence after Sol 2208. After more than 2,000 Martian days, or sols, Spirit stopped sending full-frame images. The flow of public data slowed to a trickle, even though engineers still considered the rover to be operating in a reduced mode. Within NASA's internal logs, the timestamps continued, but image releases to the public archives dropped off sharply. That silence after Sol 2208 marked the start of one of the least discussed transitions in the rover's mission, when it turned from a moving explorer into a stationary observer that few outside the team realized was still active. Spirit had long surpassed the life it was built for. Designed for about 90 sols, roughly 3 Earth months, it continued for more than 6 Earth years. Early on, engineers discovered that dust buildup on its solar panels would limit power. When Martian winds occasionally cleared them, they recalculated its energy budgets and stretched operations season by season. They learned to steer around failing components, including a front wheel that shorted out near year 5. By running the rover in reverse and carefully tilting it toward the sun during winter, they preserved both mobility and science returns far beyond what its aluminum frame was meant to endure. That durability created a pattern of adaptive improvisation, but it could not outlast physics. Around Sol 2208, data logs began showing signs of a low-power fault. This mode shut down all activity except essential survival tasks. A rover in that state would still wake periodically to try to communicate and send basic readings, but not full images. Yet in catalog records, a handful of unpublicized entries appeared, metadata suggesting that files labeled as image mosaics were received but not distributed. These were not press-ready panoramas. They sat in internal directories as technical files tagged as unstaged. The downlink process for these files relied on a 3-step chain. First, Spirit transmitted packets to an orbiting relay like the Mars Odyssey spacecraft. Odyssey then forwarded them to Earth through the Deep Space Network, a global array of radio antennas that communicate with distant probes. Interruptions in this chain were routine, caused by orbital geometry or competing mission traffic. But gaps rarely lasted as long as the one that followed Sol 2208. When images finally arrived, they were not immediately processed the way earlier panoramas had been. Earlier in the mission, large mosaics such as those from the home plate region were polished into public press kits within days. Each release came with context from the science team and labeled points of interest. The later images broke that rhythm. Files turned up months later in technical archives in their original engineering format without captions or color balancing. One example is the jarosite mosaic, identifiable by internal codes in the image headers. That dataset included fragments of Spirit's final surroundings, captured during unsuccessful attempts to free itself from loose, mineral-rich soil. At the time, those incomplete panoramas remained invisible to most of the outside world. Inside NASA, this delay had a practical explanation. The mission was down to a skeleton team. Many shifted to newer Mars operations. Processing staff and resources had moved elsewhere. The hypothesis that images were intentionally hidden never matched internal documentation, which points to logistics and verification procedures. Before any public release, teams had to confirm sensor calibration and metadata accuracy. That step slowed dramatically once full operations ceased. Eventually, after engineers confirmed Spirit's silence was permanent, the missing image sets appeared in the planetary data system. They were quietly posted without new commentary, just another incremental upload in a vast archive. Their presence confirmed that the rover attempted to record its environment, even as its systems faded. What had seemed like absence turned out to be a backlog, clearing after closure. From that point forward, attention shifted to what those recovered files could reveal about the place where Spirit came to rest, and what its final camera frames had truly captured on the Martian surface. What the final images revealed. When the final frames were decoded, they showed more than dust and metal. They revealed an unplanned geological clue and the quiet end of a rover's journey. Spirit had come to rest at a site that engineers named Troy, a shallow depression of fine, powdery material that looked harmless, but acted like quicksand. Beneath the top layer, the rover's wheels had churned up bright toned patches unlike anything in its earlier travels. The soil here contained jarosite, a mineral formed when water interacts with iron sulfates. That made Troy scientifically valuable, even though it became the rover's trap. Spirit had become embedded on Sol 1892. Every rotation of its 5 working wheels only dug it deeper. The terrain consisted of dust mixed with loose, granular silt that offered almost no grip. The mission team tested escape drives in a simulated Mars sandbox at the Jet Propulsion Laboratory, adjusting commands for weeks. Each command sequence risked further power drain. Every maneuver sent small vibrations through the real rover's structure, but no measurable motion followed. Still, the logs showed consistent energy readings and functional science instruments, keeping hope alive that Spirit could change roles instead of ending its mission altogether. By Sol 2155, NASA officially reclassified Spirit as a stationary research platform. The new plan focused on gathering as much data as possible without movement. Engineers had to decide whether to conserve power for communication or to continue active imaging. In this phase, every watt-hour mattered. Mars receives only about half the sunlight of Earth, and accumulating dust reduced that even more. So the team shifted to a strategy that favored selective operations. The microscopic imager, a fixed-focus camera used for close-ups, and the panoramic camera, or PanCam, both remained in working condition. Using these tools, Spirit collected detailed views of disturbed soil layers around and beneath its belly. Those layers told a story about ancient water. The exposed light-toned material sparkled faintly, even in unprocessed frames. Later, analysis identified silica and various salts, minerals that typically form in liquid water environments. The findings supported earlier results from the home plate region, showing that at multiple points in Gusev crater's history, hot fluids or groundwater had altered the rock. Jarosite's presence added weight to the same conclusion because it forms only in acidic, water-rich conditions. For a rover that started out studying volcanic plains, discovering that much of its final habitat had been chemically transformed by liquid water was a strong finish to a long investigation. Meanwhile, mission engineers kept adding a human rhythm to the new routine. They tracked sunlight angles and modeled how much energy each possible tilt could generate. The term Winter Tilt Campaign came into use as they planned Spirit's final posture before the cold season. A small difference in panel angle could mean the difference between night survival or radio silence. These adjustments consumed planning cycles normally used for driving instructions, but reflected how the team adapted down to the last sol. Internal reports later showed that image releases slowed because the calibration checks were still being completed. It was a necessary part of data verification, ensuring every pixel had accurate brightness and color references. The unprocessed sets stayed offline until the verification pipeline cleared. There was no evidence of suppression, only a delay caused by reduced staffing and careful cross-checking. The last panorama made it through that process months later. It showed the tilted horizon, the scarred tracks from the immobilized wheels, and ripples of soft soil encircling the rover. The view confirmed that Spirit was permanently mired, yet it expanded geological insight without a single additional drive. The images quietly demonstrated that even stationary, Spirit kept operating as a productive science unit. What had begun as a failed mobility test transformed into data that reshaped models of the site's history. That transformation linked Spirit not only to opportunity, but to perseverance, which later continued the same search for ancient water on Mars, guided in part by what Spirit had uncovered at Troy. Legacy in silence. Spirit's final images were never secret artifacts. They were unprocessed data from a rover that exceeded every design limit. Their quiet arrival in the archive reflected NASA's methodical process, verifying image calibration and metadata before release, even after operations had ended. That discipline shaped the way Curiosity and Perseverance now handle their own data pipelines, balancing speed with accuracy. Spirit's endurance, from its Autonomy updates to its immobilized years at Troy, taught engineers how to trust robotic judgment. Those lessons remain visible in today's Mars programs, proof that perseverance in science often continues long after the last signal fades.